good. All right, guys. My name is Murat. I'm a Cypress ambassador, and I work for Extend as a staff engineer in the developer experience group. So with Cypress component testing, maybe you've been using end-to-end tests for a while, and you're interested in rolling out Cypress component testing, trying it out at your organization. Then this presentation is for you. Now, I've been talking about Cypress component testing for a while. Last year at TestJS conference, I talked about Cypress component test-driven design. A few months ago, collaborating with the Cypress component testing team, we did a workshop. I compared React testing library to Cypress component testing there. I even wrote a book called Cypress component test-driven design. It's free and open source. You can check that out. I've been very passionate about it. And maybe you're passionate too, and you want to try this out at your organization. But how do you get buy-in? How do you convince all the stakeholders that this is a good idea? It's worth trying out. Let me tell you what we've done at Extend a little bit. We were using Cypress for end-to-end testing for about a year. This is January 1st. We had our first commit there with 3 component test specs. We had 79 end-to-end specs then. And as of last week, we have 346 specs, over 1,000 tests. And we have even less end-to-end tests because we converted about a quarter of them to Cypress component testing. So we piloted it in one application. We're finishing the migration of some old enzyme tests into CyCT, and it's going really well. The conversation will be about 4 big topics. So first, what can you do as an individual to learn and teach Cypress component testing? What happened at Extend, and how can that be an example? How could you have concrete takeaways about adopting it at your organization? And finally, I'll share the survey results from Extend engineers. Everything starts with you guys. You have to become an expert with component testing so that you can save other people from putting in the same effort. So think of yourself as a force multiplier. The more expertise you build, the more time you'll save for everyone else in your organization and the community, perhaps. You have to become fluent with your framework of choice. Cypress component testing supports all these and their meta versions and more with plugins. So you have to get that developer hat on and become an expert there. One thing you can do is start accumulating examples. I did my part for the React community. Many examples here, been forked many times. I'm happy that it's helping other people. You can do something similar for Angular, for Vue, whatever framework you're using. You may be doing some other repos. So this is from my book. There's a Vite version and a Webpack version. It's the full application. I'm going through each component at a time, adding component tests, adding end-to-end tests, seeing how everything works together. I've been through other resources, many books, many guides. Each one of them, I added component tests. So this is something you could do. For instance, if you're doing Angular, you could go through their docs, which are very nice. They have tests in Karma, so you could be adding component tests into that. It really helps people out when you make comparisons between something they've been using versus what's in the Cypress ecosystem. So I did a presentation and a blog post about sign-on versus Jest. I did another one about component testing, Cypress versus React testing library. So you could be doing something like vtest versus CyCT in Vue. So let's say you invest the time, you learn things really well, you're ready to go to the next stage. Let me tell you what happened at Extend in the past year. So our setup, we have 3 main applications, 80 engineers. A third of these are platform, 2/3 are product. Out of the product, about 15 to 20 are UI engineers. We're mostly backend heavy, Node and TypeScript, AWS ecosystem there. And we have front end in React. For state management, we use React Toolkit, RTK query, also known as, and Jotai in one of the applications. One of our applications began using React testing library before Cypress component testing was out of beta. And we have plenty of Enzyme that we're migrating out of. So our pilot application, we've been migrating out of that and just a little bit left there. Under that, we have Jest for unit tests. And in this context, unit tests are things that don't have to render into a DOM. And we had been using Cypress end-to-end tests by the time we were considering Cypress component tests. That was a year, and we were pretty well established with Cypress end-to-end testing. And the DevX group, we own the component library. So if you're an organization that has multiple applications, you probably do have something like a component library where you develop things once and then every other application is using those. And usually these don't have much testing or enough testing. We didn't have much to speak of. In my previous company, it was the same situation. There was no testing at all. And these components are interesting because we allow them to be configurable in many different ways. So that's always interesting for me because there are no tests. There's so many ways to test them. At best, they're being tested in basic sanity ways. So I think that's a good opportunity to start rolling out Cypress component testing. And for some reason, with component libraries, you have no opposition to these. So it's always a good, nice foot in the door to begin with. I think component library testing with component testing is a super nice fit for combinatorial testing. So in this test model paradigm, what you're doing is, let's say you have this component catalog. There are things like color and emphasis and other parameters that you can play in the component catalog if you have Storybook, for example. And all it takes with the combinatorial modeling is that you identify those parameters like color, emphasis, size, and then you put in the possible values. And if you think about this, like 5 times 3 times 2 times 2, that's, I think it's like 60 or 80. There are plenty of tests, but the idea is that it gives you a very capable fault finding subset of these tests given your model, and you just implement your component configuration based on that. So how does that look? Here's one component in 16 different variations where there are so many. So the more combinations that are possible, the better this is. Sometimes there are 80,000 and you can reduce that down to like 20. Anyway, we just take our component, mount it in the DOM with its different variants, test them all, and then finally take a visual diff. So we're fully covered for how this component might be failing in the real world. We have very high confidence this way with our component library. So that's something you can apply. It's an exciting thing if you don't have much testing. The first wow moment at Extend, you might run into something similar. And people are asking about how to test a certain thing with React testing library. So this is the normal approach. We're having to mock a lot of our component, like 80% of our component. They mocked out RTK query, React router, forming, and they're getting some error. So I suggested, hey, why don't you try doing this the easy way? And they were just mind blown how things could be easier. So on the left, we have just an RTL example, and that's on the right, we have the SciCT example. We have so much effort going into mocking over here, but we don't have to do that with Cypress component testing. We could if you wanted to, but we don't have to. Cypress component tests are easy to create, execute, and maintain. So this is our test suite with over 1,000 tests, and this is the past 2 weeks. The flag is so little that we never maintain this. We don't scrutinize the quality of the component test suite much because it just doesn't take that much effort. And the built-in retryability is so much more stable than, for instance, Enzyme or RTL tests that run a CI that try to do meaningful things with the component. As soon as you start trying to do meaningful things and you're in CI, you have to deal with a lot of flake, and we just retry the CI, which is terrible. You never have to do those things with Cypress component testing, and you don't have to maintain it. They're very, very stable. As with any change, you have to remember the change curve. This is from the book called Primes. And if you click on these resources and links in the presentation, by the way, they'll take you to the reference material. And I shared the link in the chat before. So what this is saying is basically, anytime you're rolling out change, you'll have some visionaries and early adopters in the group. Let's say you have a group of 8 people. This means 1 or 2 people will be your target audience. The early adopters are important because they ask good questions and they move on with that information. And they have followers, right? The early majority follows them. So if you get them by, 1 or 2 people, 2 or 3 people are going to follow them. The remaining 2 or 3 people are going to be under the impact of bandwagon effect. They don't want to be left behind. They follow the early majority. And you'll have 1, 2 people that are the squeaky wheel. They're the laggards. They're hard to distinguish versus the early adopters. They also ask good questions. The difference is that they just don't move. And they kind of thrive on the attention. So it's not really worth the bandwidth to try to invest in these individuals. They'll either move with the organization at some point or they'll just maybe quit. So you'll have a similar situation. Invest in the early adopters. I invested in 3 to 5 people and they took off. They did the whole thing. As soon as I had their buy-in, they were just spreading the information and the rest followed. So that was a story at extent. Let's talk about some concrete takeaways that you can use at your organization. How can adoption go for you? You want to remember the Kano model, and the resource here is at the link, but basically what this is saying is a graph of satisfaction versus fulfillment. So let's take Cypress as a test tool. Anything you're rolling out, new features, you want to remember okay, this is going to have some basic features, like the test framework has basic features. And if you don't have the basic features, people are very unsatisfied. But if you have so many of them, they're not that satisfied, right? They're fulfilled, their needs are there. These are the must-have, self-evident requirements in your feature set. The performance, stability features, those are competitive. Not having them or having them is linearly beneficial or detrimental. So these are things like your stability of your, let's say, Cypress core product. And the differentiator, the new exciting stuff. If you don't have them, people are not dissatisfied. But if you have so much of them, they're very satisfied, but the fulfillment isn't that effective. So you want to keep a good balance. Basically, what I'm trying to tell you is you have your end-to-end tests in there. You want to ensure that they're running very stably and reliably before you start rolling out Cypress component testing. Don't try to introduce these new exciting things unless you're doing what you've been doing in a satisfactory way until now. We had some performance issues. So we thought, okay, let's solve all the E2E problems that we have in place. We started doing office hours every day. And we started realizing a lot of these issues that people had been okay with, they've been living with. But to a senior engineer who's been doing this kind of thing before, that was just unacceptable. So you're seeing this, your tests are loading for a long time with end-to-end tests. Each test was taking 20 seconds to start. Whether they are a 1-minute test or a 5-second test, there's this 20-second start time, but even when you switch things. So that wasn't a good experience. You may have seen a few of the resources that I shared online about optimizing your plugins, tasks, your command file, your end-to-end file, and whatnot. You might have seen the ES-build preprocessor that I've been talking about. This 20 seconds for us after these optimizations became 1 second. Of course, we took care of all the test quality issues and the information sharing and education, and we brought end-to-end testing to a nice place. If you're interested in these kind of core product improvements, thumbs up to these two issues. One of them is about HTTP2, which will speed up the initial startup, and then the way your switching test is going to be also faster. The second one is more about what the ES-build preprocessor is solving. So my wish is to see these as a part of the core product versus performance and these kind of improvements having to be workarounds. So they're not problems for us. You can make it better for yourself too. But then moving on, with component testing, you want to use custom mounts. So you want things to be as simple as they just mount the component into the DOM and they don't have to worry about how it should be working in the context of your application. The component just works. They press the buttons, everything's there for the engineer. So you might have this situation where you have all these wrappers and providers to make your component work in the application. Well, in the component test, things are going to have to be similar, right? Your component is all the way here, but it needs all these other things sometimes to be able to functioning within the context of the DOM. It's not that different than the application, but you don't need all that overhead in your tests, right? You want to eliminate this kind of mental overhead because when the developers are using the component in the application, they're not really thinking, hey, what does the upper level of the application have to wrap this component with? So you do that same kind of abstraction with a custom mount, then you can reduce that necessity. I recommend at most not that many custom mounts. So we have a simple one that has some fonts and styles. We have an intermediate one like the store wrap mount that is handling the Jotai store or the Redux store. And we have an advanced one. So 3 of them is enough, simple, intermediate, and advanced. So this is an example of the store wrap mount. By the way, you can find the code sample at this link over here. So basically, we're mounting our component and we're passing in a default store or a custom one that we can configure. We are wrapping it with the Redux provider and then browser router from React Router down. So when the component gets mounted, we don't have to worry about, hey, this needs Redux or this needs React down. It just works. Route wrap mount is sort of one level above that. So it does still have the store wrapping from Redux. On top of that, it's doing certain things that React Router DOM is doing in their own tests. So we totally looked at their things and realized how they're testing their own things. And then we thought, okay, yeah, we could just do it this way too, because we have some components that are taking their data from the path that they're on, and they're working with that. And this third custom mount, by the way, we put everything else that's needed in there. And at the end, it became this optional object that's highly configurable. The point is don't have too many custom mounts. Like have a simple one, intermediate one, advanced one, and then let your engineers use the one that they need. Now, if you've been using Cypress Intercept for mocking, you're on the right path because mocking takes a lot of work, and in a funny way, ironic way, it's counter to the confidence that you're getting out of your testing, right? Because you're testing less of your component the more you're mocking. You can totally mock at a lower level with sign-on. I did a comparison of sign-on versus jest before. Sign-on is just as, if not more capable with jest, with some additional abstractions. But rarely you have to do this. In our tests, maybe 10% of the time. If you've been using Cypress Intercept and or mock service worker in the React ecosystem, you're on the right path. So you have your code and you have some certain things that are causing these network requests. You want to mock the network requests. You want to do less mocking at your code level. If you can combine that with custom mounts, you're in business. Lots of profit there because once you have this kind of an example, so we were doing all the mocking, internal mocking of the component, and it became so much less with a few custom mounts and Cypress Intercept. You combine that with the Cypress API, that's money. It's a lot less code to deal with. It's higher confidence because you're mocking less of the component, lot less to create, execute, and maintain. So for us, that's money, right? Less effort, more bang. We really like that. Let's talk about reach. So as we started more and more component tests, we started having more and more of them. We use Faker heavily, and Faker is a 32 megabyte import that doesn't have any named import, so it ends up importing everywhere. And Cypress component tests have to use your applications bundler and Webpack for this flow. So we had this issue over time. At the initial start, component tests are taking 2 minutes initially. So whenever you do Cypress Open CT, you have to take a bio break, come back, and then maybe you're okay to go. That wasn't okay. We don't like that at all. So our solution was, hey, let's start tinkering with the new technology because it benefits the browser. So I've been pretty excited about this because it brings that 2 minute down to 8 seconds for us. So it solves that problem. And I've been talking about how to migrate from Webpack to Vite, a few other pointers, and you can find all those resources over here. So if you're also considering migration, you could intermediately support both Webpack and Vite. So let's say this first one is a Webpack script with the browser and config. So this just gets past all the intermediate steps and gets you into the Cypress component test. But with Vite, all we're doing is this additional environment variable that we call the bundler that we're just passing in. So this could be your Cypress config file. You have the Vite config, Webpack config, maybe doing some extra things with the Webpack config, like we do some code coverage, for instance. There's this nice plugin from the component test team, Vite plugin, Cypress ESM. Lachlan and Mike Plummer helped us a lot with this. This is a simple setup of that. Works great for us in our 1,000 tests. Then you have your dev server. So based on the environment variable, if it's Vite, you use the Vite bundler with the Vite config. Otherwise, you use the Webpack bundler with the Webpack config, and then just passing your dev server. It's that simple. So what does this enable you? I can start my tests with Vite or Webpack, whether local or CI. I'm saying, cross-browser testing is overrated. I think it's cross-bundler testing right now that makes the most differences because that's where you find the issues. But these are only local to you. And Vite is under development. So it doesn't have first-class support yet. Locally, it's working great for us, headed or headless. But in CI, occasionally things fail. So this is where we're at with Vite right now. We're collaborating with the CT team. So if you have these kind of challenges, check out this issue, thumbs it up, and let's hope to see first-class support for Vite in the near future. So we covered what you could do as an individual, what happened at Extent, what you could do at your organization rolling out Cypress component testing. I want to share some of the survey results from Extend engineers. So coming up with this presentation, I had a lot of help from Cypress team, not component team only, but Cypress team, especially from Jess. And we had a meeting and I basically said everything I wanted to say, and they took nice notes and we put out those bullet points together, and then it became this presentation. So they created a survey and sent it to our engineering team. And out of the 15 or 20 UI engineers, 14 people took it. Now, here are some of the results. How often do you use CT? So we're seeing that about a third of them less than weekly, 28% of them every week, 28% of them every few days, 7% of them every day. How likely are you to recommend Cypress component testing to other developers? 7 people voted 4/5, 7 people voted 5/5. How would you describe your experience getting started with Cypress component testing? Some people had a little bit of issues, but they were able to work through them. 40% of them had no issues. The SciCT onboarding is quite easy. I mean, I think it's a very nice experience. When do you typically write Cypress component tests? This was something we're very happy to see because this means that about a third of the engineers are actually utilizing Cypress component testing as they're creating their component for that immediate feedback and iterative increments. This is exactly what we were hoping for to begin with the developer experience group. But we were always promoting, on one side, you have the browser. On the other side, you have the text in the terminal. So you have access to all dev tools, network, everything that may be happening with your component versus some HTML in the bash. You have this visual feedback, and unless you spot issues, you haven't written tests for. So maybe you have this custom hook in React, and it's over ambitious. They may be doing some network calls and some extra ones. You would never see something like that if all you have is the terminal, right? And in the real application, there would be so many other hooks like that it's very difficult to isolate what your individual component is doing. So this kind of observability in a smaller focus was what we were promoting. And final question for people to give their final opinions. They love the simplicity of use, visualness of the product, observability into the component in isolation is a game changer. Browser feedback, no more mocking, RTK query and Redux, easier to mock the network, easy to write and debug, the ability to view the components while testing is very nice. Easy to test components without having to mock almost everything, easy mocks, rendering. So they love the custom mounts and the ease of mocking because that saves them most the effort. Some more feedback over here, not having to mock every single piece of Redux gives more confidence in the test overall. It's a lot faster testing individual components and scenarios where you don't necessarily need to test things each week. So we have, I think, by this point, moved a quarter of the end-to-end tests into SciCT. They run faster. They give us the same confidence. We always go for lower cost without reducing the confidence, and that happened at extent. We have less and less end-to-end test now. Just makes sense, very easy to use. Mock actual network requests rather than mocking hooks, so there's some coverage on that. Easy to run and debug individual tests. Being able to see the DOM is a game changer. I'll work on components that may not be fully integrated into the app yet. Component tests let me build them out with the state and network requests and exactly know what they will look like. So this is just excellent, right? This is what we're looking for. I constantly recommend Cypress component test to engineers at other companies. So our engineers really like it. Wrap up. Consider Cypress component testing. I think the feature set, the speed, the simplicity, make it a top contender for the future of component testing. Build expertise, first start by yourself. Your efforts will save many others from having to do the same kind of work. You want to solve the current problems first, have E2 at a good quality, utilize custom mounts, network level blocking, abstract the right things. This is all I wanted to share. I shared the slide link in the chat, so you can check those out at your convenience. That's all.